Hey guys, Frank Macaluso here from Garageaholic. Welcome to the channel. If you're new, you are entering into our third to last episode on the E30 N54 swap. Yes, we have 2 more episodes before our finale episode coming up in the next couple of weeks. Today we're going to be taking care of a smorgasbord of items, including but not limited to exhaust tips, TIG welded. We're going to be doing a full exhaust system completely welded. We're going to be doing parking brakes. We're going to install Castle's DME, which has been completely tuned and flashed. No CAS, no codes. We are looking for some really good performance out of this new DME from Castle. Thank you for that. Guys, we got a really good show coming up. And even if we're lucky, we might even do a test drive by the end of the episode. Stick around, you don't want to miss it. Okay, now it's time to replace the parking brake cables because I clearly destroyed the old ones when I was removing the trailing arm bushings. Do my exhaust tips, and I want to TIG weld them, and I want to do it right. So here's my plan. I wanted to do 4 pie cuts, 2 for each side, with a straight tube in the middle, so it basically offsets each one of these, right? Offsets each one of these in and then straight out, right? So that's the idea. But what I need to do is, since this is slightly larger than 2.5, the pipe that I have is actually 2.5. I'm sorry, it's slightly larger than 3-inch output, and I have a 3-inch tube, and it slides in, which is I think the way it's meant to be. So I'm gonna actually have to try to I'm probably gonna end up MIG welding this ring here, and then everything else is gonna be TIGged. So I wanna TIG, I wanna learn how to TIG, I wanna do it well. So I prepped my parts. Here are my parts. I have 2 pie cuts, 18 degree, another 2 pie cuts over here that are 18 degree, and here are my flat pieces. These are basically going to be the straights. So what you do is you take the straight and you put it on the pie cut just like that, and then you take the other pie cut and you put it like that, right? So you kind of get like a bit of an offset look, right? So that's kind of what I want to go with, and I want to line up the weld marks so that everything looks nice, and then TIG it with this DC TIG, and tack everything in, and just see if the offset spacing that I had calculated is exactly what I'm looking for. I think it is. I think it's really close. So let's do a couple of TIG tacks, and see how this turns out on the actual muffler. The 2 sets of pie cuts. So you see pie cut, right? So like a pie cut, this is an 18 degree pie, then a straight, this is about 3/4 of an inch, maybe a little bit more, and that is the other pie cut. And basically what it does is supposed to offset, and when you have 2 of them, actually these are exactly the same. So if you take this one and turn it like that, you have basically 2 that take a wider input and make a narrower output, which is exactly what we want, because we don't want 2 exhaust outputs to be like too far away. It just looks weird. So we want to put them together and have the outputs be really, really close together, or as close as we can. So let's set this up and fit it up on the muffler, give it a quick MIG tack, and see how they will look. All right, so I got them tacked, and this might not be the final position of where these things are going to be located, but I do have them where I think I might want them. And if I were to just, let me just put the camera up here and just face these. There we go. All right. So I have two pieces here that I don't think they are going to be the final configuration because the seam is not on the right side. The seam you really want to be facing down for the most part, and that does not face with the angle that I have this cut. So anyway, I marked the top of the angle so at least it looks pretty normal. And as you can see here, the outputs of these is going to be pretty darn close to what I want. And then when I get these in the right position, I'll just TIG those. But yeah, I like the offset of these. And actually, you know what? Let me TIG them, and then or you know, just give it a quick MIG tack, and then I'll show you what it looks like. All right, so this is what they look like tacked up. So from the top, looks pretty good. Looks nice and even, which is what you want. You want two parallel lines. From the side, looks pretty good. I like the angle, but I think I'm actually going to go with a little bit more of a steeper angle. This is a 9-degree angle. I'm actually going to think I'm going to go with a 20, so it's going to be cut even more. Nice aggressive look. Nice finished tips. I like the lengths, and I just like it. So what I'm going to do is I'm going to take these two off. I'm going to redo just the outer tips and make sure that the seam is on the right side. And then I'm going to take the entire 3-piece assembly of each of these guys off and then TIG the whole thing with the tips on. So yeah, hopefully this turns out okay. So we have our 2 TIGged tips. All right. These are, as stated earlier, these are 2 18-degree pie cuts. There's a straight, and then there is a 20-degree bevel on for the tip end, and I also embedded a 2.5-inch outlet that is mirror polish finish, mirror polish. So I ended up welding that in. You can see it's actually pretty nice. It's actually a pretty cool design feature that it was difficult to add, but I figured it would be worth it at the end. And I think it will when everything's all set up. The reason, again, that I angled them like this is so that they can both face inward or at a very close proximity to each other, given the very far apart outlets of the actual muffler. And that's why I ended up angling them like this. So why not make this a design feature and TIG all this? So I need to practice the TIGging and then I'll do it. The TIGging that the TIG welder that I'm using is an Eastwood TIG AC/DC 200. And I'm going to be in DC mode because I'm going to be TIGging stainless steel. And AC is for aluminum. And I'm going to be using a stainless steel filler metal. This is a 308R, or L actually, rather. And there's 2 different sizes, but I'm going to be using the smaller size, which is a 1/16 inch size. This is just a tiny, tiny little piece, and you just dip it in as you go and make your weld. Now, I'm no expert, and that's why I have a Chinese Eastwood version of the TIG welder, because I'm not ready to spend $3,000 on a Miller or a Lincoln. So I'm going to practice on a couple pieces before I actually work on these, and then we'll do a time lapse on this and see how things are turning out. Now, just remember, I actually did polish this. The outside, I put it on a wire wheel brush. That's why you can't really see the heat dissipation marks on the TIG weld, the tacks. So I wanted to polish it to get a nice clean slate, and then as I weld, then those new heat marks will end up showing through. You can actually see them on the underside. See? That's what it would look like on the outside, which is kind of what I want. So let's try this and see how things work. All right, I got a little bit of practice. I'm not going to show you the results. Took about 15 minutes to really get it down, I think. I think I got it. Now let's do it on a real thing. Let's do it on the real tip. I'm really nervous. I'm not going to lie. I put a lot of time and work into this piece, or both of these pieces, and I really don't want to mess it up. So wish me luck. Here we go. One ring done. Not bad. Not bad at all. That took about 4 minutes to do one. You got 1, 2 more. And I got 3 on the other side too. Let's go to the other one now. All right, so I just finished this guy here. This one ring on this. There's 3 rings on this side, 3 rings on that side, so I have 2 more on each, so 4 total. More rings to go. It takes me about 4 or 5 minutes to do each ring, so I'm gonna do them later. I wanna let this cool out for a little bit, but I wanna talk a little bit about the welds, the quality, and as you can see, that it's all in the prep. Now, I really took my time in prepping these tips because I wanted to have really good TIG welds, and it paid off, in my opinion at least. As you can see, I very rarely grabbed the extra filler rod that I talked about earlier, and the reason is because the way that I prepared these, I beveled each one of them, I sanded them down. There's no metal shavings or shards on the edges from the bandsaw cutting. And when I TIGged them together, it made almost a perfect connection all around on the entire circumference of every single one of these connections. And because of that, the TIG weld basically just fused the 2 pieces of metal together. And what I did was I basically just took the gun and I just kind of went back and forth like a zigzag position. Or sometimes I circled, but I just wanted to make sure I got even coverage on either side of the weld. And I did. I really think that this turned out really good, and I'm really excited to do the other ones. I'm not nervous anymore. I mean, I'm learning, I'm getting better, and I'm really excited about that. Yes, that's right. I'm getting better. I'm learning how to do things better. I'm learning how to TIG. I'm learning how to MIG better. I'm learning about electronics. I'm learning about integration and steering geometries and all that stuff. I'm doing that all at the same time. So I'm basically a jack of all trades who's very, very slowly getting good at every skill. So you guys are gonna have to forgive me if you're a little bit more critical about something that I'm doing. I will get better at it. You have to believe me on that. And hopefully as I learn, you learn too. So I'm gonna finish up these tips, and then I'm going to start moving on to the next thing, which is going to be wiring. Let's work on reverse light switch. One of the most understated updates that one needs to do on a car when they do an engine swap. Needs to have the reverse lights, right? You gotta let people know you're backing up. This is a simple harness that I had gotten from an N54 E90, and it's got 2 wires. This side plugs right into the transmission, and these 2 wires go into the same location onto the swapped car, in this case the E30, where you would need to then close the connectors, close the contacts when reverse is activated. So I figured out where it is. It's right down here in the center console. There's a switch right here. You can see that guy right there. It's not a multi-position switch or multi-pins. It's just 2 pins. And so if I were to jump these guys, I have the ignition on, so if I were to jump these, there we go. They're jumped. You'll see that the reverse lights turn on. So all we need to do is plug in this switch into the transmission. We need to wire up these 2 wires to those 2 wires, and we can test it. On the E90 transmission, the reverse switch is located right there. There it is. So very simple. You just install your connector. Go until it snaps, and you got to route it up through into into the cabin. So I got plenty of wire here. It's going to end up running up and around and over into the cabin, and we'll snake that around and we'll take a look inside. All right. Okay, so I got my 2 wires here from the transmission. I got my 2 wires here to the reverse lights and power. So I just need to cut, splice, create a connector, and it has to be removable, right? I mean, I want to make it removable so it's easily removable up here and down at the transmission, so you can remove just that little harness piece. But for now, I just want to basically crimp, create a connector, and put them together. All right, ignition is on. Car's in neutral. No lights. Let's put her in reverse. Got my lights. All right, now let's start tackling the cooling. There are a number of elements involved with the cooling system, none the least of which is, of course, the radiator that needs to get installed, upper, lower radiator hoses, and then the hose that branches off the upper radiator to the heater core, and the other one that comes from the water pump down below, and that one also gets snaked into the heater core. But we also have the coolant reservoir as well, and the reservoir needs to be installed, and we all know where that's going to end up going, right here. But there's a special hose that comes off of the outlet of the coolant reservoir, and we are going to be teeing into this line right here to ensure that when we fill up the system through the coolant, through the reservoir, that it adequately fills up the system just like that reservoir is designed for and the engine is designed for. So those are basically the elements of the cooling system that we need to install today. So let's go on ahead and get that started. All right, we got our upper radiator hose here. I skipped ahead a little bit and just kind of did a little bit of this on my own. But it's really simple, right? It's just a regular 5/8 or 3/4 inch hose, and it goes around, it goes up to the upper heater core. And the lower heater core is going to go down underneath. It's going to tee off into the coolant reservoir, where I have my tube, where this tube, well, then I'm going snaking into that. It'll go through a 3-way T, and that other half of the T is going to go down below and connect to this guy, which then goes up into the water pump. So let's do a time lapse on getting that installed and getting the coolant reservoir installed. Remember, I have my level sensor here that I can conveniently end up wiring up to the C101. It's one of these 2 wires here, so we can do that as well. But I'm actually going to do that in the wiring section, so don't worry about that. I'll just cover that in the wiring section. But for now, we'll finish up the plumbing and get this reservoir installed. All right, I think I got it. The reservoir is in its location, and let me get light on it. What I'm going to do is I'm going to make this a permanent solution. So I put a really tight 90-degree tube on there, and it's basically going to go straight down. I have a Oetiker clamp here for really good clamping, and that's going to go down to the T, and the T, one side of the T is going to go to the heater core, and the other side of the T goes to the tube that's coming up from the water pump. So I'm going to install it that way, and I think it'll hold just fine. I mean, this is all low pressure, and I'm using an Oetiker clamp, or high quality Oetiker clamp, which means that it's making pressure contact around the entire circumference perfectly equally. So it's not going to, it's going to really help with any type of slipping off or anything like that, but that's going to end up being now part of the coolant reservoir, just kind of like this is, right? I think it's perfect. I think it'll work just fine. Okay guys, cooling is done, but not without a lot of effort. I thought it would actually be easier. Final assembly is usually easy, but this time it was not. Cooling has been difficult, giving me a lot of problems, especially with the heater hose hookups over there on the firewall. Getting the coolant reservoir installed was a tough one because we were dealing with, the T down there that goes to the heater core and to the pump, so we had to deal with that as well. So yeah, a lot of work that's been done on getting the cooling system up and running. But this is good to go. All we need to do now is get this bleeder installed there. I'm not ready to do that quite yet. I actually created another bleeder here on this T. I know it looks a little bit cumbersome, but there is a bolt on the top there that can be used as a high point bleeding, actually expedite bleeding when you're doing your initial fill. So hopefully that'll come in use. Now, if you're interested, we're gonna be talking the boring stuff, wiring. That's right. We have to make sure that we can wire this whole thing up with the new Castle standalone DME, no CAS. It's very, very easy to do, and I'll show you the specific wires you need in order to get the DME to fire up, as well as the connections from the C101 over the flybridge to the electronics bay, and of course, OBD2 for diagnostics. So let's talk about that real quick. So let's talk OBD2 wiring, right? We need to diagnose the DME when the engine has a fault, right? We need to be able to connect to INPA and for other random standard code readers, and I need to hook up an OBD reader, right? So you need seven specific wires. You need your can high and your can low. You can see here, yellow is the sun, it's high. Green is the grass, it's low. So that's how you know what can high and can low is. And I also have a 120 ohm resistor across those bridge contacts. If you want to know a little bit more about how to wire up the can and use the 120 ohm resistor as a terminator so that the computer can read the actual data, well, then take a look at my integrator's guide. It has all the detail on where and how to install that 120 ohm resistor. You also have two powers, which will be your pink and red, right? Two power pins. You'll have two ground pins. That's your black and your brown. And then, of course, this white wire is your tack. You need your tack in order for the DME to output engine speed, and that the computer can read all that appropriately. So you have 7 total wires, and they go into the specific pins onto the OBD connector. This is just a generic OBD connector with pins that I had bought on Amazon. Really, really cheap. I bought like 10 of them actually because of all the projects that I do. It's really good to have an extra set with pins. Crimp it with a weather pack crimper, and you're in good shape. So let's do that and get them not only crimped and finished, but also pinned and loomed up. We got to loom up all this wire. All right, so let's talk C101 for a quick second. What I want to do here is I want to basically take all of these C101 connections right here and connect them, as many as I can that are appropriate, across this flybridge over to the electronics box for processing and connections, right? So there are a few number of wires that I need right off the bat. This guy here needs to be grounded. This is a black with a green stripe. This actual wire is for the unloader relays, and it needs to be grounded. So whenever the key is positioned on, the unloader relay clicks off and it turns everything else off before you start the car. Very important, and it affects a lot of the internal, basically the power that's coming from the fuel, from the actual battery to the fuse box. It's controlled by this black wire with a green stripe. This black one here is your tack. That needs to come from the DME. These 4 here are your thick wires. 2 of them are accessory power. 1 of them is your fuel pump wire, this purple one, and then this black with the yellow stripe is going to be your starter wire. So those need to be snaked over there as well. These 2 here are your oil level static and dynamic wires. The oil level static needs to be grounded because we don't have oil level that we can sense here. It needs to be through CAN, so it's not going to be a discrete wire, so we need to fool the active check control. And in order to do that, we're going to end up just grounding the static, and we're going to be putting a 1K ohm resistor in line with the dynamic in order to fake that so that we don't have any light on in the active check control. Finally, we have 2 more wires here. This one is a brown with a purple stripe, and that is for your coolant level sensor. The other wire is a 2-wire sensor, but the other wire is going to end up going to ground. And here is your oil pressure. This is a black with a brown stripe. That's your oil pressure. That's going to end up going to the dash. It's snaked in to the actual oil pressure sensor here. So those need to be connected as well. All these others here are for fuel rate output or check engine light, and other silly stuff that we don't use. It's not silly, but we just don't use it. So anyway, I highlighted all the wires we need to take here and route across for either grounding purposes or signal purposes. And as I said earlier, I have a number of these wires here that I've utilized for spares, and I'm going to mark whichever wire I use for this so that my customer knows exactly how the car was wired at the end of the day. So let's do a time lapse and basically dress this whole thing up so we have the interconnections between the engine and the car. Now, one more thing I'd like to note is that the 3 wires that are coming from the engine, directly from the sensors, right? These 2 wires here, the white and the orange are coming from the temperature sensor. That's going to be connecting into one of these wires here. And the other one is your oil pressure. It's going to end up going to the oil pressure wire. Because this cannot be hardwired onto that because it's part of the engine harness, engine ever gets taken out of the car, then you need to disconnect it. So I'm going to put this through a 3-wire pin, a separate connector, so that it can be disconnected at any time. Okay, so let's do a time lapse on that and get that done. This is a big part of the wiring that I wanted to focus on and get this out of the way. And I want to finish it and get you guys all set up on this part, and then we can move over to that part. Okay, so the wiring to the C101 is done. I did not clip these wires off because I wanted to make sure that I didn't need to use them exactly, that maybe I've gotten a wrong wire on there for the active check control, but chances are I'm good. So anyway, this section here, the 2 wires again are for coolant temperature and the 3rd wire is for oil pressure. That is disconnectable and that goes directly to the sensors themselves. So if you ever had to remove the engine, you can at least disconnect this 3-pin weather pack there. This is part of now the chassis harness, and it goes all the way across, and it will all be disconnectable over there in the e-box. So let's talk about the e-box now. All right, guys, so I know we got a lot going on in this area, and you have to mind my little Band-Aid here thing that I got. Cut my finger on a spout fan. Take a look at this. It was spinning, stuck my finger in it, broke the blade right off. Those things are really sharp. So anyway, there's a lot going on here. We have wiring coming from the C101 over into the bay. We have wiring going out of the bay into here, namely the OBD2 wiring, that's right here. And we have our accelerator cable wiring here, which is here. It's 6 wires as well. So we have to connect some of this stuff. We have to create what's called a switched power node, which is one of these offset. So we're going to be taking one of these puppies here, and we're going to be installing it as well. It's basically an isolation node, and wherever you have your stud going to this is going to be a power distribution location. We need to be using this for switched power. Remember, we have our node right here for power, and we have another node under here. See that? Right under there? Right there? That's your ground. So we have our ground, we have our power, and we have our switch power. So we got to create the switch power, and then we also have to kind of clean up a little bit about what's going on here, because there's a lot of superfluous wiring here actually that doesn't really need to be here. That we have a lot of connectors that are taking up very precious room where the DME is going to end up getting installed, and we need to slim a lot of that down. But this guy, way too long. We got to slim that down. So let's work on that right now. Okay guys, so the wiring is just about done. I know it looks like a rat's nest of wires, but it's really not. It's actually quite methodical. We have all of our wires going across the flybridge here. We have our power wire for the starter, alternator, battery. This here is our bundle of wires from C101 that's coming out and branching out into all the other places, including what we have here, which is our spare wires that we'll use if we ever need them. We have our 3 junctions. We have our positive power that's coming from battery, always positive. We have a number of different items going to that, including the fuse box, including some DME, and of course the starter. right? So it's going to the starter as well as the alternator. Here is our switched power node. Okay, this is our switched power. This is basically going to the main relay. Needs to be tightened up here. It's going to switch power from the key. This key is actually providing the switched power to this node, and it's coming out to the OBD2 port, and it's also going to this green wire with a white stripe, which is our PA bus wire. Actually, it's our 15_ZRS wire that basically goes to the X6001, which then it's basically a 12-volt signal to the pretending that it's the CAS unit. So obviously CAS is not there. But that switched power ends up going out to here, and it also goes into this other pin here, this yellow wire with a green stripe. This is a small gauge wire, and that goes into X6002. That is your wake-up wire. Very, very important you get this wire hooked up to switched power. Finally, we have our ground here. Our grounds are here. Basically, we have our grounds coming from serving as our grounds for the CO101 for grounding the static and dynamic oil level on the E30. We have our grounds for our OBD2 port. We have our grounds for the DME. So that's all taken care of there. We have our switch here for our starter. This is our starter switch, our solenoid from the key, basically, that starts the car. And we have this switch here. This connector, rather, is our TAC. It basically has a TAC coming from the cluster, and it goes out to the DME. Actually, it comes from the DME to the cluster and also to the OBD2 port for diagnostics. And we have this guy is our CAN, PT CAN, from the X6001 connector over to PT CAN high and low. High is the sky, that's the sun, and low is the grass, that is the green. So you know which one is high and low. So basically what we're going to do is, these are your two connectors. That's one there, and this is one here. And the DME basically slides into this vacuous spot and connects here, and then the cover goes over the whole thing. So what we're going to do with the cover is basically put like a foam cover over the edges to help to prevent any water ingress, but also to help add a little bit of a buffer and height to account for the additional wiring that we have here. Additional items in the N54 harness is this is the 50 amp fuse for the cooling pump. This is your main relay that ends up getting going to switched power. And we have our little fuse box here. This is a bunch of little fuses that connect power to various locations for the injectors and the coils. And we have another little fuse here. This is a 10 amp fuse for, I believe that's for the boost solenoids. So that's basically all that you see here. And we have our extra wiring here. This is our extra wiring from our X6001 that I've kind of bundled up here. I don't want to unclip them because I don't know if I'll ever need them for whatever reason. But basically this is it. I mean, there's a little bit of grooming that's still needed here, but overall I think that this is a pretty good spot. So let's put the DME here and let's see if we can try getting the cover on. All right, electronic box is done. There's still a couple of to-do items, some of which are the obvious ones, like some of the bolt holes. Everything's loose still, but I haven't tightened it because I want to do a little bit more organization inside of there. But everything seems to be in order. Flybridge is done. C101 connections are done. Even the connector that separates from the C101 over to the coolant temp and oil pressure has been completed. I have my coolant level here. This is a coolant level that needs to be routed through this harness here, which is not part of the engine harness, it's part of the body harness. I connected battery power, and so far, so good. I did not turn the key yet, so let's turn it on now. I expect the fuel pump to turn on. Everything clicked. And let's give it a start. Let's get that power steering. Ooh, power steering is low. Why is it low? Is there a leak? Nope, no leak. Ha! It's in gear. Cool. That's better. Fill it up with power steering fluid. So far, coolant's good. Cool. It's running nice and quiet. Although you gotta understand, I don't have anything on the turbos, so that's not good. That's why I'm not gonna really race the engine. I do need to get the hot air side of the intercooler plumbed up. I got the cool side done. I gotta get the hot side done still. But anyway, electronics is done, so let's move on and let's get ready for our first drive. Let's do it. I think we can do it. All right, let's see real quick if our OBD2 port actually worked. Let's go into accessory, power, go. Light turns on. Got our USB hooked up. Let's go on to IMPA. Cable detected, yes. Ignition, yes. Let's press F3. Go. Engine. N54. And it is communicating. F4. Let's read memory. See if that'll work. Should work. F1. There we go. No error memories. No memories in error. Thank you so much, Castle. All right. Looks like we're communicating, so we're in good shape there. Let's end. And we're done. That's right, guys. So I have 5 pins here. Let's get a better view here. Right. Not 5 pins. What am I talking about? I have 2 power pins. I have 2 ground pins. I have my can high, my can low with my little 120 ohm resistor in there. And I have my tack, which is the white one in this case. So I have all of my wiring that's hooked up to the DME. That's talking when you have switched power. Everything is looking good. Guys, thank you so much for watching. My name is Frank Macaluso from Garageaholic, and if you like the content of what I'm producing, tell your friends, tell your family, share the videos. I appreciate it, guys. If you guys want to learn how to do more, stay tuned. I got a lot of cool projects coming up at the end of the year. Thank you so much, guys. I am out of here. Later.